Okay, explain the trends in boiling points shown in the graph. Now there are two sets of trends to talk about. There's the trend within each of the homologous series, and then there was the comparison between the series. So if we look within any one of those series, we can see the alkanes rise as the molecular weight goes up, as does the alkanols, as do the alkanoic acids. And this trend is due to the fact that dispersion forces are evident in all molecules, be them non-polar like the methane, the alkane series, or polar as the alkanol and the alkanoic acid series are. And we know that dispersion forces gets larger for larger molecules. So we can explain the upward trend in each of the homologous series due to an increase in the size of dispersion forces for larger molecules. Now we have the trend to explain between the series. And for that, you need to acknowledge what types of attraction are between molecules. So if we go to the alkanes first, they are non-polar molecules. So the only attraction that can be evident between non-polar molecules is dispersion forces. Now dispersion forces are evident in the other two series as well, but dispersion forces are the weaker of the three types of forces. Moving on to methanol now. Hydrogen bonding is possible here because we have an electronegative element present, making that bond polar, and it's the strongest polarity possible because we have the electronegative element bonded directly to hydrogen. So the size of the attraction between methanol molecules in this position is the largest, and it's the hydrogen bond. Hydrogen bond is also evident in the alkanoic acids as well, because we can see the same feature, the electronegative element bonded directly to hydrogen, and similarly in the other alkanoic acid drawn. So again, we have the strongest type of polar attraction between molecules with the hydrogen bonding in both of those series. Now the ethanoic acid has a third type evident as well, because we have polarity based around the alkanyl group here. So we've also got the oxygen taking more than its share of electrons, leaving the carbon exposed, so it'll be delta positive, and it's going to be attracted to the slightly negative end of the oxygen, and this type of attraction is the dipole-dipole. So we have a situation where the alkanoic acids are the highest boiling points because the attraction between molecules, all three are evident. We have dispersion forces, dipole-dipole, and hydrogen bonding. So we can write them here: dispersion forces, dipole-dipole, and hydrogen bonding. The second highest boiling points are due to the next best attraction between molecules, which is for the alkanol series, represented here with methanol. We have dispersion forces evident, and we have hydrogen bonding. And the lowest boiling points would be the alkanes, because the only type of attraction between hydrocarbons would be dispersion forces. Thank you for listening.